Hello and welcome to a very special episode of the Astroholic Explains.
Welcome. So this is going to be the penultimate episode, but it's going to be our final episode that is focused on the science. We have another episode that is a fictional episode after this, and then there's going to be a little bit of a break, and then as is tradition, we're going to have our Christmas special. And then that's it for 2020, both for the year and for from us.
It's going to be a good couple of fictional episodes as well.
Yes, we're really excited about that.
Can't wait.
But I am excited about this special episode because it's going to be...
It's going to be a quickfire round episode.
Very, very exciting.
So yeah, we have crowdsourced some questions and I'm just going to throw them at Alf with, well, hopefully the answers won't be too long, so it'll be a very fast-paced episode.
Depends on the questions and depends on the answers. And obviously, if you are seeing us, it's because we decided to also have a sort of companion behind the scene of how we record these episodes, simply because we have been gifted this room by a friend.
That's a good point, actually, because if you're listening to this episode like you normally do, be sure to go and check out on YouTube because there is a video episode instead. No, that.
You see, I was planning
I'm cutting this.
Yeah, I was planning to say just this, this video part for the video people and keep all of it in, and then would be cut for the podcast. Chris instead wanted to do more. He always wants to do more. So welcome to the behind the scene of the Astroholic Explains. Shall we start?
Okay.
He is so patient with me. You have no idea. Shall we start?
Yes. Let's begin.
Let's begin.
Right. The first question is going to be one from me because I just wanted to get a question in as well, and it's not just everyone else.
Awesome. Get the ball rolling.
The ball rolling. The first question. You become the first person on Mars. Mm-hmm. What are your first words?
My first words are going to be, oh God. Oh God, no. Oh God, no. And then I cut off the feed.
Oh, that's terrifying. I like that.
No, I'm not sure. This is, I'm probably going to ask this, crowdsource this question. Mostly because, first of all, I think there's already been enough white men getting first in the solar system. So I just feel like it's somebody else's turn to have a epochal, life-changing, humanity-changing phrase. If I were to be a first somewhere in space, I think I would pick like a comet or an asteroid.
Would you have any different words for there?
Not sure. I think it would be nothing as a giant leap for, it should be humankind. Nothing, I don't think it's going to be that big. I think it would be maybe a reflection on my experience. I don't know. Or maybe it's a small step for a gay.
Small step for a gay.
Yeah,
Right.
Giant leap for queer kind. I don't know. No, but if you have any idea of what's your first sentence on a different planet or an asteroid, a comet, a moon, please do let us know in the comments or just tweet us.
Right, I'm going to carry on.
Go.
This question comes from Carl, or KJC Byrne, who asks,
Carl.
What is your favourite galaxy other than the Milky Way and why?
Okay, first of all, Carl, bit presumptuous. First of all, Carl, bit presumption. I'll do that again. First of all, Carl, bit presumption that the Milky Way is my favorite galaxy. I know it's the only galaxy with chocolate that we know of, but I don't know.
That
It's
makes
like
it the best as far as
I
I'm
am
concerned.
not too super keen on Earth at the moment, so anyway, I think the answer will have to be M51, also known as the Whirlpool Galaxy.
Ooh, nice.
Because it is the quintessential spiral galaxy. If you're picturing in your head a spiral galaxy, 90% chance you're picturing the Whirlpool galaxy. Is textbook. Also, it is merging, it's doing a minor merger with a spheroidal companion, which is much tinier. So it's a case of galactic cannibalism.
Cool.
And I don't know how many of these have you listened to, or if you follow me on social media, but you might know that galaxy mergers is my PhD topic. So I can show a perfect spirals with a merger that is like, ooh, you see? And people, I've heard of the Whirlpool galaxy, maybe because of the
I think every time
the
there's
electrodomestic company, like.
I think every time that there's a depiction of a galaxy,
Yeah.
anywhere, the picture that is going to be shown more than likely is the Whirlpool galaxy, and I think that's probably why people are going to have seen it.
Yeah. Also, you can see it with a good pair of binocular. Is only 23 million light years away, and quite exciting, but it's still in peer review, so it's. We can discuss it because it was on the archive, but we can't really be super excited. We might have discovered a planet in M51.
That's exciting.
Super exciting if it's confirmed, and it would be the furthest planet ever discovered.
Wonderful.
23 million light years away.
My favourite galaxy is the little penguin in the egg.
It's
adorable.
That is very, very, very cute.
It reminds me not so much of a penguin, more so of the meme of the, was it the bad opinion puffin?
I have no idea, but I'll make sure
it's like
that
trundling along. I really like it.
I will make sure that for the video version we're going
We'll put
to
it
have
on. We'll put it on.
little images.
So, next question comes from Ben Jack, or at Sparks of Ben, who asks, galaxies look stationary, so why do scientists say that they rotate?
Ooh, okay, this is a subtly excellent question. I'll repeat that. This is a subtly excellent question. I'm not sure if it's a little bit trolling with the how do they say they're rotating, but Benjak is right. Galaxies look stationary and took such a long time to rotate. How can we tell that they are actually rotating? And it is due to a very common effect that you must certainly have experienced. You might not know the name, but you definitely experience it. It is called the Doppler effect.
Oh, like when an ambulance goes past.
Excellent. So, taking my my example away, please describe what happens when the ambulance goes past.
No.
I thought you were going. This is the Astroholic explained.
It
not
is the
Chris.
Astroholic explains. It's not Chris explains.
Okay, fair enough. So, what happens? You have a ambulance coming towards you. So it's moving at a certain speed, which is comparable to the speed of sound. As the ambulance approaches, the pitch of the siren is higher than its normal regular pitch if the ambulance was stationary. Once it passes beyond you, the pitch becomes lower than if the ambulance was stationary. And this is because of how the sound waves propagate from a moving object. Chris is nodding, so I would assume that it's been a clear explanation. How does this relate to galaxies? So the same effect, the same Doppler effect, also happens to light. So a light source that is moving, if it's moving towards you, will be blue shifted. If it's moving away from you, will be red shifted. So if you're looking at galaxies and you're combining the entire light from a galaxy, and you measure the sort of spectrum of light, the sort of fingerprint of how light is emitted by this galaxy, you'll see that in a rotating galaxy, half of the galaxy will look a little bit bluer and half will look a little bit redder. Obviously, it's something that you cannot see with the naked eye. You need specialized equipment and techniques, but you can absolutely totally see this rotation. And you can do even more. You can measure how the rotation changes at different points of the galaxies, and it's super exciting because that is what suggested the presence of dark matter, because spiral galaxies tend to rotate in a very peculiar way that suggests there is a lot more matter than we can see with our telescopes.
The more you know.
Good.
The more you know. Next question.
Go.
We have one from Wan Feng Yung, who asks, how do we measure the speed of stars and galaxies? Surely they're relative to something else.
Absolutely. This is a case of it's all relative. I feel that the cards were a bad idea for you.
I've always wanted to do that.
You're absolutely right. It's all relative. And measuring it's quite subtle. So let's start with galaxies. So again, Doppler effect that we've just been discussing, you can use the same approach to measure galaxies. There is though one extra bit. It is important when you're doing that kind of measuring that you measure galaxies and its neighbors and the galaxies that are around there. Why, Chris? Why might be important?
Because everything is moving away from everything else.
Close, very close. That is exactly where we're going, but you're very close. So, the universe is expanding, and this everything is moving away from everything else unless they're really close to each other. So, usually, because there is this expansion, there is something that we call the redshift. So, galaxies, just by the fact that they are so far away from us, they appear that they are moving away. It's not a proper motion. They're not actually speeding up themselves. The space between galaxies is expanding. All clear so far?
Yep.
So, if you want to work out a proper motion, it's quite difficult because you have this cosmological redshift plus the velocity that could be towards us, away from us, perpendicular to us. So what we do is look at galaxies that are like in groups or in cluster. They're all more or less at the same distance. So we can work out, using the cosmological redshift, the distance. And then, using the slight variation, trying to create simulation of how the geometry of these galaxies is working in space, we can work out how they're moving, how fast they're going, etc.
Okay.
So far, so good. So, how do we measure the speed of the stars? Obviously, we're talking about stars in the Milky Way, and it's the speed that the stars have going around our galaxy. So, if they are moving at a certain speed towards or away from us, we can work it out with redshift or blue shift, so Doppler effect. But also we can do something even more detailed, even more subtle, and is through the concept of parallax. So, maths. Chris is not impressed about maths. So, you heard of trigonometry, right?
Yep.
Awesome. So, let's assume that, let's take one star in the sky, and let's assume that is fixed. It doesn't move.
Mm-hmm.
If you start looking at the star at a precise time in the sky, so obviously the star is not fixed in the sky, it's fixed somewhere in space far, far away from Earth. But you are here on Earth, and every night for a year, you measure the position of that star in the sky. Where is it? Okay, so far so good. Because the Earth rotates around the Sun, and it describes an ellipse, we are on an elliptical orbit. So far, so good.
I'll stop you if I'm confused.
Okay. The star, although is fixed in space, it will look like it does a little ellipse in the sky on Earth. Good?
Yes.
Awesome. So, what you can do by measuring the size of that ellipse, you can work out something called the parallax angle. And so you can measure the distance to that star. When we call parsec is a measurement that is implying that you have a parallax of 1 arc second, which is 1/60th of 1/60th of a degree of an angle. Wonderful. So, how do you measure the speed from there? That is that things are not fixed in space. So, when you start measuring this, you're expecting this nice ellipse, the stars have moved from the year before. So it's actually creating a weird sort of curly shape. And by measuring that, you can work out both the distance and a value for its speed.
Okay.
So that's how you measure both the speed of galaxies and the speed of stars.
Wonderful. So the next question actually comes from an anonymous person who does not wish to be named.
All right.
What's one thing in astronomy you wish wasn't true?
That wormholes are not stable.
Why? Are you thinking of traveling?
I want to see the stars. I want to travel through the universe. And as far as we can tell, based on relativity, wormholes are not stable. So we cannot travel across interstellar distances, traveling to the past. But even if it were stable on a short distance, imagine just like, okay, now I'm just gonna pop to Tokyo for a bit of tempura udon, a soak in an onsen. Oh, I'm gonna pop home and see my family for lunch. I'll be back in the afternoon. It's
no living out your Star Trek fantasies then.
It's not just Star Trek. Seriously, every single sci-fi, every single major sci-fi franchise or thing use wormholes or something akin with like warp space, stuff like that. So no, I am very upset about that.
Okay. Next question from @Nathan Brune. How many atoms are there in the universe? Quickfire question there.
Okay. Not super quick fire. We need to do a little bit of calculations. What do we have? The visible universe. First of all, the universe might be infinite.
So is the answer infinite?
Yeah, but that is not a fun answer. What's the point to say, oh, Nathan, first of all, Nathan, thank you for the question. But also, hey, Nathan, the answer is infinite, maybe. We don't know, we're not certain. No, we can do better than that.
Okay.
So, let's focus on the visible universe.
Go for it.
The visible universe, due to the expansion, etc., is 93 billion light years across, which makes it
unfathomably big. I can't even begin to picture that.
Unfathomably big, but also which makes it 10 to the 27 meters across. So that is slightly less than a billion meters across.
10 to the 27 meters sounds so much smaller.
I know, and it gets worse. So we're talking about volume. We need to talk about volume. Sorry, in my head it's already clear what the calculation I need to do, but you're not in my head. So we need to talk about volume because we, actually not we, but humans have been able to measure the density of matter in the universe. So bear with that thought. Let's make it super simple for us because we don't know the geometry of the universe. We assume that the universe is three-dimensionally flat. Alfredo, what does it mean, three-dimensionally flat?
That would be another question.
But yes, let's go with it. Let's just make our life easy and just cube our 10 to the 27 meters. So you get to 10 to the 81 meter cube. So it's a lot of billions. We don't care. Big number. So you might think, okay, how many particles are there? The paper that came out just a couple of weeks ago put the amount of matter in the universe to be about 6 protons per cubic meter.
Sure.
But you can imagine, like, cubic meters, like that, 6 protons, because there's a lot of empty space. But that's not all matter. That is our average based on the fact there is also dark matter. And regular matter is about 1/6 of the total matter density of the universe, which makes it quite easy. It means that there is 1 proton per cubic meter.
Okay.
So we have an upper limit. The upper limit is that how many atoms? 1 proton can create is the nucleus of 1 hydrogen. So our upper limit is about 10 to the 81 atoms in the universe. We can make it slightly more precise, but it's not going to change much. So about the composition. The composition of the universe, the composition of the Milky Way. That is something that is in my head. Composition of the Milky Way: 72% of the Milky Way regular matter in the Milky Way is hydrogen. Nice and easy. 73. 20. I think it's around 73. 24% is helium. So that should take us to 97, 98. I think it's closer to 98. And then the rest is all the other elements. The third most abundant is oxygen, which is about 1.4% of the Milky Way is oxygen. So if we go with 74, 24, and 2% to divide things, you have so 74 for every 70 for every 100 atoms you have 74 hydrogen, 24 helium, and 2 oxygen. That means that based on the amount of protons, how many would you have? 74 remains 74, 24 you need to adjust because there is protons and neutrons in both helium and oxygen. Picking the most common elements, you usually would get something around, for 800 protons, you would get something around 641 atoms. That's what you have. So probably your answer, the 10 to the 81 was an upper limit. I would put a more reasonable answer to between 10 to the 79 to 10 to the 80 atoms in the universe. I know this wasn't really fast.
No, it's not really a quick fire question after all, was it?
Sorry. But thank you, Nathan, for the question. It was brilliant.
Okay. Another question from Carl at KJC Byrne. Where in the solar system should we send a probe next?
In the words of Lady Gaga, to the planet Venus. Come on. Okay. Enceladus and Europa are a lot more likely to have life, and they're probably going to have a lot more exciting things. Titan is going to be so much more exciting. Is the only other world in the solar system with liquid something on its first surface. It's methane, but it's still liquid and exciting. But Venus is really close. And I really, really, really want to know about the phosphine.
So speaking about the phosphine,
okay,
like, would it be possible if we did send a probe to Venus with like a sort of, I don't know, a space scoop or something that can just like...
a little Hoover.
Yeah, a little Hoover that can just sort of suck up a little bit of that Venusian atmosphere and bring it home for us to analyse. Is that possible?
There are certainly missions looking into that. There is a Russian mission that wants to do everything, wants to get on the surface, get a sample, then fly into the atmosphere, a sample from the ground, then fly into the atmosphere, get a sample, and then just shoot itself back to Earth. So there are a lot of very exciting ideas, but you have made an assumption with your, actually several assumptions with that question. You wanted to grab a little bit of Venusian atmosphere to find the origin of the phosphine.
Yeah.
What are your assumptions?
What are my assumptions?
Yeah, there.
One, that we could scoop it up. Two, that it's dense enough to be scooped up. Three, that in doing that it would survive the trip home. Four, that we would even be able to discover the origin of this phosphine. Five, that it would survive the journey.
You already said that. But 4 is key. So
what was 4? I forgot.
That we will be able to discover the origin of that phosphine. I think your underlying assumption there, which it's only natural, and sometimes I think in these terms, but we shouldn't, is that the origin of that phosphine is something in the atmosphere that is constantly producing it just by being in the atmosphere. That is a sort of underlying assumption that it is a living organism.
So you're suggesting that if we were to scoop it up and bring it home, it would just die because it's not in its
natural
habitat?
No, it's not that it just died, because ideally you take a lot of the atmosphere. The issue is, what if it's not a living organism? So if it is, if you haven't heard the news about the phosphine on Venus, I did a really good explainer on the Astroholic YouTube channel, and it's also on the website, etc. But in very simple terms, researchers discovered this molecule called phosphine in the atmosphere of Venus. It's super exciting because it's a molecule that should be destroyed pretty quickly by the extremely acidic environment of the atmosphere of Venus, but it isn't. So there's something producing it. So researchers look at I think 74 ways to produce phosphine on Earth, or at least the way that we are familiar, that don't involve living organism, and none of those ways could work on Venus. So there's either geochemical, so something happening on the surface of Venus or underground, because we believe that Venus is volcanically active, or there's something in the atmosphere happening with UV light from the sun, or potentially a living organism that somehow is surviving the extreme condition of the acidic atmosphere of Venus. So if it's not a living organism, just taking a sample of the atmosphere and bringing it back home is unlikely to give us any answer. We might find out something really exciting about Venus.
I was going to say, I mean, it'd still be worth sending a probe there and finding stuff out.
Like there are a lot of missions thinking of how can we get as close as possible to Venus and study as well as possible. And this is why I answer Carl saying, let's go to Venus.
Venus it is.
Venus.
Right, another question from me.
Okay.
Do nebulae look as colourful and pretty in real life with your naked eye as they do in photos?
Since you're an artist, you probably would say, I will probably have to say no. I would say they still look pretty, but obviously the colors are a lot more muted. This is often the case also for a lot of planetary pictures, not all of them, is the fact that astronomy turns to enhance photos. Okay. First of all, most images have different filters, so it's not like seeing it with our proper naked eye. Look, it's like a camera. It's looking at filters that collect light slightly different way, and so often have they can see more light than the human eye. Sometimes it's even combined with infrared, ultraviolet, X-rays, so a lot more than what the human eye can see. So different colors needs to be assigned. But even the things that are just visible, the colors are enhanced because they allow us to see details better. So having in real life, the colors will appear a lot more muted, but they still look very pretty. But I would say, if you were inside a nebula, you would only see the fuzziness at the edges. You wouldn't be like inside a cloud. Nebulae are very, very, very the density big. Yes, they're huge, and the density so is very, very low.
Yeah. Right. I'm going to throw another question at you.
Okay.
Another one from Benjack at Sparks of Ben. Are there any other planets you would downgrade to a dwarf planet, or any natural satellite you would upgrade? And I would like to make an addendum to this question.
Okay.
Because obviously it's not just a case of if you would like to downgrade a planet. So I'm going to say, if you could download a planet out of spite, which one would you do?
So if I downgrade a planet out of spite, okay. I think I'm going to be extremely spiteful. Actually, not even spiteful, just chaotic. Mm-hmm. I would upgrade, or actually reclassify Titan, because as I said, the only other world with liquid on its surface, thick atmosphere, and then I will downgrade Saturn. We're gonna have a dwarf planet binary.
But it's so big.
Yes, okay. But you see, I think there is an issue here with, and I blame the Americans for this, that we consider the fact that Pluto was reclassified as a dwarf planet a downgrade. And I don't think is correct to say that. Obviously, it was the only planet discovered by an American, and at the time of the reclassification, there were a lot. There was the New Horizon mission been launched for I think a few years, so there was a lot of writing on this idea that Pluto is so important. But Pluto is important even if we call it a dwarf planet, and I think we should expand the classification. I think dwarf planet counts as planets in the same way, and we just need to start putting labels in a better way, like Mercury, Venus, Mars, and Earth, rocky planets. Then we have Saturn and Jupiter, gas giants, Neptune and Uranus, ice giants, Ceres, Pluto, Eris, dwarf planets. We create a classification because it simplifies the way we try to understand the world. But even, for example, gas giant planets, it's a complicated classification because we're starting to discover so many. They are roughly the size of brown dwarf, which are objects that are stellar-like, but are much smaller, and it's very difficult, a lot of these objects, to understand if they are brown dwarf or just something really big, only a little bit bigger than Jupiter. So it's complex. It's pretty much our astronomical taxonomy is far from perfect, and we are walking towards a moment in which we will have to reckon with this classification. But
it seems to be an ongoing argument constantly.
It is a constant argument, but what I would say is I never learned of the existence of Ceres, which is the largest body in the asteroid belt, until I got to university. And I would say that Ceres was discovered by an Italian, so even in Italy, I should have had in school something to be, oh, this is something that we can be proud of, etc., etc. Because Sirius was for a while considered a planet until they realized that it was just too small, etc. What is, I think it's important now, a lot of schools teach that there are 8 planets and 5 dwarf planets and a lot of other minor worlds.
That's good.
Suddenly you are putting these minor worlds on the map, and I think it's so important that is happening.
That's really
so
good.
I think it is a positive thing. But I'm happy to hear a counter argument about why everything should be a planet.
We have 2 questions next from 2 separate anonymous people.
Ooh, okay.
First, based on its name alone, do you have a favourite place in our solar system?
Yes, the Mordor Macula.
Oh, wow. Is that on? Wait, hang on.
Okay, where is it?
So, obviously named for J.R.R. Tolkien's range of mountains that surround Mordor.
Just Mordor.
Or just Mordor in
Just
general.
Mordor
Okay.
in general.
If I'm not mistaken, there are more...
You want me to translate the Latin?
No.
Macula?
Only if you think it'll help.
I have no idea. Macula means spot.
It does not help.
Okay.
Well, I mean, it would suggest to me, spot would suggest Jupiter, but I don't think it's on Jupiter.
No.
I think...
It is a geological feature.
Yeah.
So
There are another geological feature named after Tolkien's work, which I think are the Iron Mountains, and I think, if I'm not mistaken, they're on Titan.
the Iron Mountains are on Titan.
Yes.
Gold star to Chris.
At last.
Yes, the Mordor Macula is not on Titan.
Mars,
Nope.
Pluto,
Closer.
Ceres,
Closer in geographical sense rather than...
Neptune.
No, around Pluto,
Oh,
but not on Pluto. So? Around Pluto, but not on Pluto. Around Pluto, but not on Pluto.
one of Pluto's moons.
Yes. Which one has...
Charon.
Yes. North Pole of Charon
Okay.
has this red zone that is called the Mordor Macula. And we believe it is because some photochemical reaction is happening in the very tenuous atmosphere of Pluto and is being blown onto the its moon,
like that.
Charon.
The next question. What would happen to Earth if we blew up the moon? Everyone wants to blow planets up.
I was about to... So this is another anonymous, right?
It wasn't Steve.
Okay, it wasn't Steve. Okay, so we had in episode 15, lovely Steve, who asked about blowing up Earth, and we realized that it takes so much energy to just completely destroy our planet, and we had to invoke stars and rogue planets and black holes and supernova just to make sure that we could destroy it.
If someone blew up the moon, what I think would happen,
Tell me.
it would mess up all of the tides,
Correct?
but I don't know in what way. So it's either going to stop waves, full stop,
Not exactly.
or it's going to do the complete opposite and there's just going to be constant global tsunamis because there's no moon to keep it in check.
Okay, first of all, we need to start with a much earlier question. How are we destroying the moon?
Blow up.
Okay,
It's going to
so
be blown up.
it's going to be blown up. You're extinguishing all life on Earth because where do you think those bits of moon are going? Haven't you watched Umbrella Academy? Like, they're coming down on Earth.
Spoilers?
Spoilers. That's season 1.
More spoilers. I would have a shield. If I was to, then I would have a big shield in front of Earth so that none of those bits
Made of
could-
what?
Diamond. Something impenetrable.
There is no such thing as something impenetrable. So, let's assume that you are not going to destroy it by blowing it up and then killing everyone on this planet in the process. You're gonna somehow throw it into the sun.
What if the... Okay, yeah. Yeah.
Somehow you're gonna throw it into the sun. What happens then? As you said, the tides. What causes the tides on Earth?
The moon. Wind. I don't know.
It's the gravitational pull of the moon and the sun.
Okay.
So, without the moon, there's still going to be tides, but they're going to be much lower. Tides are very important because they help circulate water on Earth, in the Earth's oceans. So even if you just push the moon away, you're going to have that crucial effect. And the fact that there's going to lead to maybe definitely thousands, if not tens of thousands, 100,000 million species going extinct in the oceans, and by consequence, species going extinct everywhere. Oof. And we're not finished. The moon also helps stabilize the tilt of the Earth, which is the reason why we have seasons, because the Earth is at an angle in its orbit. So without the moon, the tilt is going to start varying again quite significantly. And that will probably end up changing season. Maybe we're going to get to a point in which there are no seasons. Again, more extinction, etc. So, even if you can push the moon away in the most gentle but firm approach, you still
say no.
Yeah,
no more moon.
No more moon. Good night, moon. And it's still going to cause huge harm to life on Earth.
So not a good idea.
Not a good idea.
Let's keep the moon.
We keep the moon. We like the moon.
The final question is from me.
Fantastic.
Big surprise. If you were able to harness the energy of the sun through use of a Dyson sphere, which, if you're not familiar with the term, it's basically a hypothetical machine construct that you would use to surround the sun and use its energy, and you would get masses of energy from it, what would you do with all that energy?
Destroy the moon.
You just made such a good argument for destroying the moon.
Okay, what do you want me to do with all that much energy?
You could do so much. You could basically do everything. But to tie it back to an earlier question,
okay,
you could use that energy to make a wormhole stable.
We don't know if we can make a wormhole stable even with that amount of energy. But I don't know. I don't think it's clear just how much energy the sun emits in terms of luminosity. I don't think it's... You might have, like, tell me how many, I don't know, millions or billion times or whatever big number you can think of in terms of how much energy from the sun reaches the Earth or the total amount.
I have no idea about energy quantities from the sun.
So I remember the power produced by the sun, which is energy per second, simply because it is how we calculate luminosity. So it's about 10 to the 26 watts. Okay. 26 zeros.
Okay.
The energy consumed by humanity, not the energy, sorry, the power, is about 10 to the 13.
Okay, so it's much, much more.
A lot. So consider that the power that we get from the sun to Earth is 10 to the 17 watts, which means that if we could harness all of the power that just gets down to Earth, we could power 10,000 more civilization like ours.
Okay.
If we have a Dyson sphere, 10 to the 26 is another 10 trillion civilization like ours in terms of power consumption. That is enormous amount of...
I can't even picture it.
Exactly. So I really don't know what you would do with that amount of energy. First of all, I know that there is all this idea that civilization got more and more and more power hungry, but it's just like it's an enormous amount. I really, with what I know, I cannot picture what you would do. The only thing that sort of springs to mind, there was an idea to sort of, if you wanted to shift the entire solar system.
Would that kind of turn the sun into like an engine?
Yeah, and there was this idea that you would use the sun and you will need a huge amount of energy to use the sun as an engine and literally just shift the sun and it will drag the planets with it. But even that, I don't think it would use a full Dyson sphere. So I have no idea.
Move it there and back again.
Yeah, I have no idea, but if any of you has any suggestion,
What would you do?
Yeah, what would you do with a Dyson sphere covering the sun? Please do let me know. And I think this is it.
Yes, that was the last question. I think that's a good place to end.
Fantastic. So, as I mentioned earlier, we have 2 more episodes for you in 2020, and there are going to be 2 fictional episodes. We really hope you enjoy them. One is going to be getting 2 weeks standard for our episodes, and then the next one is going to be just before Christmas.
Thank you so much to everyone who sent in questions.
Yeah, thank you so much. This was very good fun. If you have more questions between now and when the podcast starts again, feel free to tweet me, either on my personal one or at the Astroholic, or email me or comment on any of the social media. I will get back to you. And until then, have a good time.
See ya.